Well, ladies and gentlemen, the EU Commission has recently announced Europe's digital decade, the ambitious digital targets Europe set for 2030. Quantum technologies play an important part in that, and the most prominent being the building of the first quantum computer within the secure and sustainable digital infrastructure section. Quantum Technologies in a Digital Decade. That's the title now of Gustav Kalbe's talk. And Gustav is head of Unit High Performance Computing and Quantum Technology at DG Connect at the European Commission. Gustav, the floor is yours. Hello.
Hello and good afternoon to all of you. It's a big pleasure that I have been invited to this very illustrious round to give you an overview of the different activities that we have now in the Commission on the quantum technologies in general, and give a bit more emphasis on the quantum computing part. I trust you have listened to the keynote speech by our DDG, Mr. Thomas Skodas, earlier in the session, who highlighted the big, let's say, policy communication on the digital decade, which in a nutshell defines the objective that in Europe the Commission sees in the digital transformation for the next 10 years, sets clearly measurable targets where we want to be in digital in the next 10 years at the European level, but also at the member states. And quantum computing is a very prominent component of this digital decade. It's so important that if you just count the pages compared to the other digital technologies that are mentioned there, the number of pages is far the largest on the quantum computing part. So you see the importance that the European Commission is putting to the quantum in general as an enabler for the the digital transformation. And playing a key role also on the other policies like the industrial strategy, the data strategy, and so on. Now, let me explain you in more detail how the different programs or activities that we are now having in the European Commission at the level of the European Union, how they are interlinked, what are the different priorities, and ultimately, what is the relation with also the national programs. Not so long ago, we're just talking 2 or 3 years ago, it was a huge success that we were in a position to launch a quantum technologies flagship, which is a research and innovation program, basically to bring the results from the research labs into the real life, to come closer to the market, to establish practical products and applications. And today, this innovation and research program is complemented by a number of other large initiatives that also cover a couple of billions that I will highlight in a minute, which address the 3 pillars that Mr. Skodas mentioned in the keynote speech. So the flagship as an innovation program is complemented by other fundamental research programs in quantum, and Ms. Schieferdecker just mentioned Quantera, which for us again is a huge success and is adding another 150 million or so of collective European funding in the research of quantum technologies. Now the big, let's say, innovation or the big novelty for the next 7 years is that we are going beyond simple research and innovation programs, but we are moving higher up in the value chain by doing development of infrastructures to really take advantage of the results that have been developed, for example, by the flagship, put them into a real environment, expose them to real users to accelerate the maturation of those quantum technologies, and have in a co-design approach the suppliers of those machines with the users that can play with it, with the developers, with the scientists coming together to further develop those systems and all the ancillary technologies. It's also an incentive for our industry or startups to invest in the commercialization of quantum products, because here we're creating a first market where we're going to buy those machines. And we are having now the deployment of a quantum computing infrastructure through the EuroHPC Joint Undertaking, where the quantum computers will be combined and connected to the classical high-performance computing machines. We're doing a similar development of quantum infrastructure in quantum communications, where the ambition is to deploy across the Union in a fiber network, but also connected with satellites, a secure quantum communication network infrastructure for protection of critical infrastructures, sharing of keys, and other applications. Now, this is something we are now about to establish, is the Quantum Technologies Fund, which responds to the last question that was raised to Ms. Schieferdecker, which is an equity fund where the Commission will buy some shares of the startups companies to help them bridge the gap between the development of the product and coming to market. And last but not least, the picture would be incomplete if we leave out all the big and ambitious programs we're seeing now coming at the national level. We see them now coming from many and more countries, and we need to ensure that there is a coherence, there's synergies, there's a connection between the European programs and the national programs. Now, in the most immediate actions we're going to launch very quickly in the Quantum Technologies Flagship, we are planning to move into the second phase to come closer to the practical large-scale quantum computers, where we're building on the results of the first generation of flagship projects. Of course, we keep the door open for other emerging approaches to quantum computing that might be a solution for the longer-term future and might be solutions that could scale higher or that are more compatible with the traditional microelectronics-based production processes. Of course, it's not just about developing the quantum computers themselves, but the whole software environment, the whole applications that go around it. And similarly to what we're doing in quantum computing, we will also address the quantum simulators. I will not mention here also the activities we plan to do on quantum communication and quantum sensing and metrology, because the focus of today is on quantum computing, but rest assured that those activities are equally important and also covered in the flagship. A big novelty we're introducing here compared to the first round of flagship project is that we are accelerating now also the question about production manufacturing, where we intend to establish pilot fabrication lines that will assist and help the developers, the startups, the scientists, the industry to run small productions, small batches of their quantum devices and progressively scale up to then the mass market manufacturing capabilities that are compatible with the traditional microelectronics or photonics production lines. Now, quantum computing and high-performance computing, we see that this is converging. And the question is no longer if quantum computing will replace high-performance computing or not. The question is rather which type of applications, which type of problems is best addressed by either type of architecture. And we are seeing quantum computers as standalone machines or as hybrids in combination with the traditional HPC machines. That's what we call, for example, the accelerators that we are now developing through the flagship, and which will be one of the big milestones we intend to achieve in the digital decades. I don't have to insist here how powerful the intrinsic computing power is of the quantum machines. The question is how we can in the short term make progressively usage of this quantum computational power, and by when it will be at the level of performance that it can compete and meaningfully complement the classical high-performance computing supercomputers. Now, we have we're lucky that we have the UHBC Joint Undertaking that has as a core mission the development and operation and acquisition of a high-performance computing ecosystem, making available the supercomputers, which has also already started to acquire quantum simulators, and which we'll be using, as you can see on the slide, in the next years to acquire progressively more and more quantum computers from the first generation, second generation, combine them with the classical high-performance computers, so that by 2030, indeed, we will be able to place in the high-performance computing and data infrastructure in the Union quantum computers that are presenting the quantum advantage and that are accessible to any user in the Union for his application, be it pure quantum application, be it hybrid quantum / HPC. Just some quick words on the Quantum Technologies Fund that we hope that by the autumn we'll be able to launch. The idea here is to take shares, to take equity in the startups, to help them establish themselves in the market. I would say, luckily, we're not the only one having this idea, and I'm quite happy that we have very good talks with the German Ministry and the KfW to have a combined or coordinated action here. And we have similar talks with other countries like France that have also similar programs, so that at the end we can make sure that sufficient funding is available to really support the emergence of a European vibrant industry on quantum technologies. Now, a couple of days ago, I was very happy to read the German quantum strategy that was also presented here today by the previous speakers, which is very ambitious, very strategic, and very smart strategy. And if you look closer about the objectives, about the approach to implement the strategy, you can see that the European strategy and German strategies are not very far apart. And if you look into the French program or the Dutch program, the priorities are similar, the approaches are similar. So for us, the real question here is from the European perspective is, how can we bring together the different programs, the different efforts to reinforce our respective policies, to close also the competence gap or capabilities gaps that some of the national programs have highlighted, to really pool our resources and be able to compete on the worldwide scale and develop the European quantum industry to address questions like the digital sovereignty that was also mentioned by the previous speaker, but also to maintain the quantum competences in Europe and attract the talents that we need in Europe. Now, last word just on the figures. We always criticize that in Europe we are investing very little compared to what other regions in the world are doing in quantum. But I always like to show that in Europe we have a tradition of working together, of good cooperation, of synchronizing our programs in pooling our efforts, so that if you add all the national programs to European programs, if we really achieve of linking them together, we don't have to be shy on the investments that Europe collectively is bringing on the table. Just some last words. I mean, this picture on what we do in quantum in the Commission and in Europe is getting more and more complicated. So one of the burning questions that we now need to address within the Commission, but more importantly with the member states, is what is the governance that we put in place so that we can get all stakeholders, all actors around the table to really collectively agree on the strategies, on the priorities, and pool our efforts to bring to a success the digital decade, what my DG likes also to call the quantum decade, and come to a setting where we can really have communication platform to coordinate our efforts and resources. So that's my last slide to the conclusion. So we have now in the European Commission now programs that address basically the full value chain on quantum. We are quite happy to see that what the Commission has identified as priorities and as roadmap is also very close to what is happening in the member states. And our big homework now is to make sure that with our counterparts in the member states, we find a good governance to be able to pool our efforts and collectively advance the development of the quantum technologies. Thank you for your attention.
Well, thank you very much, Gustav. Kalbe, and well, was a very positive outlook on what to come and the collaboration between the member states and the EU and, well, even globally. Thank you very much, Gustav Kalbe. We need to move on for time reasons to the next slot already. Our speaker is online, but, well, you certainly, you can be there in the chat and answer questions as well. Thank you very much.
My pleasure.